Welcome back to Algebra 2, folks. We're going to get started with today's lesson with first just a little bit of a math joke. We've learned FOIL. Use it. It'll turn out better than this. It won't foil your plans. It'll foil your problems by solving them. In this lesson, we're going to talk about quadratic equations. We've looked at quadratic expressions before. An equation will be set equal to a particular quantity and will have a solution. So any equation whose highest degree term is a squared term is going to be called a quadratic equation, and we will learn today how to solve them by factoring. So a quadratic equation will have this form: ax squared plus bx plus c is 0. A, b, and c have to be real numbers, and a cannot be equal to 0. So again, hope you'll have committed that equation to memory. Ax squared plus bx plus c, that is the form of a quadratic expression. In order to solve a quadratic equation, we need to remember the zero property. We've looked at this before last year, but by way of review, if p times q is 0, then either p or q has to be 0. They both could be 0 as well, but at least one of them has to be. Because let's say p is 4. If 4q is 0, then q has to be equal to 0. And the same would be the other way around. So when we are given a quadratic equation like this one, our first step is going first to try to factor anything out. Is there a greatest common factor that we can take out or divide out of the expression? In this case, there isn't. The leading coefficient, the a term, has the coefficient is 1. So we're going to look for a number whose product will be negative 24 and whose sum will be positive 2. So think of the factors of 24 who have a sum of 2. And some variant of 6 and 4 should present yourselves to mind. Since it's negative, since this term is negative, 24 is negative, one of these will have to be either negative 6 positive 4 or 6 and negative 4, and the second will be the correct answer. So we'll factor this expression. So now we will use our zero product property. If this expression, x plus 6 times x minus 4 is equal to 0, then either this quantity will have to be equal to 0 or this quantity will have to be equal to 0. One of them will be equal to 0. To find out the values of x that satisfy that, we set both halves of the equation equal to 0, and then we solve for x. So this quadratic equation will have two possible solutions. X will be either negative 6 or positive 6. So when we factor quadratic polynomials, we're going to make sure this equation is written in standard form. Don't assume that the question is given to you is going to be in standard form already. You might have to use some algebra to get the problem into standard form. After you've done that, factor the polynomial. Then apply the zero product property to set each factor that contains a variable equal to 0. Usually there will be two factors, like in the example we just saw. Sometimes there'll be more. We'll look at some examples of that shortly. And then we'll solve the resulting equations, and we'll move forward. Example 2. I could copy this down, but remember, I first have to put this equation into standard form. It's not there yet because the 11x, that's my b term. It should be the middle term according to standard form for quadratic trinomials. I'm going to rewrite the equation like so. Let's try to solve it now. The leading coefficient is not 0. It's 3. I can't factor anything out. So I'm going to have to replace this middle term by finding numbers that have a product of 18 and a sum of 11. So product, sum. What numbers satisfy those requirements? Well, 9 times 2 equals 18. They have a sum of 11. So I'm going to actually insert a step here, 3x squared plus 9x plus 2x plus 6 equals 0. Now I'll do some factoring. I'll take this 3x, these first two terms, I'm grouping them, and I can factor a 3x out. And I think I made a mistake in copying this out. 3x squared plus 9x. There's no x squared there. So we've got that. And the second part, we've got 2x plus 6. I can also say x plus 3. 2x plus 3. Let me write that. There we have it. There should be a 2x there. 9x plus 2x, that was at 11x that we replaced there. Well, now we've got we've got two terms in the expression. We've got this term and this term. Both of them, I can factor out that x plus 3. So I'll do that. X plus 3 times 3x plus 2 will be equal to 0. Now I'll use my zero product property. I'll say x plus 3 equals 0 and 3x plus 2 equals 0. Now I solve for x. X in this case will equals negative 3. If x has a value of negative 3, then the whole term, the whole quadratic equation would have a value of 0. On this other side, 3x will equal to negative 2. X will be equal to negative 2/3. So here are the two values for x that, if used, would result in the product of 0. I have now solved this quadratic equation. Let's take another example. 6x squared equals 8x. We notice that this is not does not appear to be a quadratic equation. But if I say that the constant is 0, that might help. First off, to make this simpler, I'm just going to divide both sides of the equation by 2. I've got a simpler form of the equation. Now, I'm going to put it in standard form. 3x squared minus 4x plus 0 equals 0. So the constant is not listed. The constant is 0. I still can be said to have this equation can still be said to be in standard form. Now, I'm going to factor. Both terms on the left side of the equation have an x. So I can factor the x out. X times 3x minus 4 equals 0. I can use my zero product property here because I've got this term times this term equals 0. So x, one possible solution is that the x would be 0. If x is 0, the whole equation would be equal to 0. We have that value. Or I can say 3x minus 4 is 0. X would be equal to 4/3. These are my two possible solutions for this equation. Let's take a look at another. Go back in this other example. Notice I did not divide at this step. I used my zero product property. I did not divide both sides of the equation by x. Why not? Don't do that because that could eliminate a solution. If we had said x times 3x minus 4 equals 0, and I simply say, oh, we'll take out this guy, and 3x minus 4 equals 0, I would have gotten just one solution, and x would have been equal to, have the value of 4/3. I would have missed the solution that x could also have a value of 0 to make the whole equation have the value of 0. We can also work backwards. If I'm given the solutions to an equation, x being negative 1/2 and 3, I can work backwards and actually write a standard form quadratic equation based on those solutions. Let's say we do that. Well, here we have it. X is negative 1/2, x is 3. This means I can take this step back. If x is negative 1/2, I can multiply both sides by 2 here. 2x minus equals negative 1. I can add 1 to both sides. And here I've got one part of my quadratic equation. I can do the same thing to the other two at x being 3. I can take negative 3 from both sides. This would be the second part of the quadratic equation. Now I've multiplied them together. This is the factored form of the quadratic equation. And now I can FOIL this problem. And now we get 2x squared minus 5x minus 3. This would be the standard form quadratic equations, having worked backwards from the solution. This is pretty cool. Many equations with a degree higher than 2 can also be solved using the zero product property. Remember, if I say that an equation has a degree higher than 2, it just means that one of the exponents on the variable to the variables is cubed to the 4th or 5th power, etc. We'll see how this could work. All right, as I solve this, I'm going to put it in standard form first. At least my first step to that is to put all the terms in descending order on one side of the equation. So cubed term, squared term, linear term. And now I'm going to, each of these terms, the x cubed term, the x squared term, the linear term, has an x. I'm going to factor that x out. And now we see I have an equation or an expression here in the quadratic form. X squared, linear term, constant term. The leading coefficient is not 1, it's 5. That means I'm going to have to find two numbers. Product is going to be negative 14 times 5, which would be equal to negative 70. Whose product is negative 70, but whose sum is positive 3. Now, what are the factors of 70 that have a sum of 3? Well, one of them one set does come to mind. We can take 10 times 7, but since this constant term, 14, has a negative sign in front of it, one of these factors will be negative. So I have to take negative 10, 7, or I could take positive 10, negative 7. Which one of these sets gives me a sum of 3? This one does. So let's try to work this out. X will be equal to 5x squared. Now I'm going to take this 10 and the 7, and I'm going to substitute them for this middle term. Plus 10x minus 7 minus 7x minus 14 equals 0. What order do I put them in? Why did I put the 10 first and the 7 second? Well, my next step is going to be factoring. I want to put the 10 in this group with the 5 because they can factor out. I put the 7 in this group with the 14 because they both share a factor of 7. So we will take this, and this first group will be here. I'm going to factor out a 5x, x plus 2. And in the second group, I'm going to factor out a 7 minus 7x plus 2. And here I've got it. Well, at least I have it. I have factored the expression. Where do I go from here? Well, I'll take this term. Using my zero property, x could be equal to 0. Or I could say, well, I missed one step. It's 5x minus 7, x plus 2. Because these two terms share the x plus 2 factor. So I've made this x could be equal to 0, or I could say 5x minus 7 would be equal to 0. So I take 5x equals 7. If x has a value of 7/5, the whole expression of a value of 0. Or I can say x plus 2 equals 0. So if x equals negative 2, the whole expression would have a value of 0. So those three values are the solution to example 5. Now we'll take a look at what we can do with word problems. All right, so we have a launch pad that's currently 10 by 12. The engineer says we need to increase the area of this launch pad by 75 feet. What distance can be added to both the length and the width of the 10 by 12 pad to meet this requirement? Well, the new length would be 12 plus x, and the new width would be 10 plus x, whatever I'm adding to the length and the width. That would be whatever I'm adding to the current length and width would be the dimensions of the new requirement. So we could also, we're more used to writing this x plus 12 and x plus 10 in our equations. Because of a commutative property, it doesn't matter. What will this new area be? Well, 12 times 10 gives me the area of the current launch pad. And the engineer says that the new area says the current area has to be increased by 75 feet. So the new area of the launch pad has to have will be 195 feet squared. Now we use this 195 and we can write a quadratic equation. We've got 12x plus 10x is 195. What value do I have to increase this by? I use I FOIL this problem. I write it in standard form, and then I go about factoring. This is written in the leading coefficient is 1, and I can, so I have two numbers to have the value of negative 75 and the sum of 22. Well, we can say 25 and negative 3 would satisfy those requirements. There we have it. I set each of these values to 0. And these are the solutions to my problem. In a word problem, I cannot assume that every solution will be a realistic solution. For example, this first value for x, negative 25, is it possible to increase the area of a launch pad by adding negative 25 feet to the original? No, this is an extraneous solution. A distance cannot be negative. So the only solution I'm working with here, I'd have to increase the length and the width of the launch pad by 3 feet, and that would meet the engineer's request. We'll look more at these problems together. For now, you can get started on your assignment for tomorrow. 1 to 11 odds, and then 47 to 51. These will be review problems from chapter 1 in your book. If you have trouble with them, review sections 1.4, 1.6, 1.7, 1.8, 1.9. We can look at them in class tomorrow too if you have too many cobwebs. Until then, good luck.